So this is our second lecture this week with one of the best presenters we ever had at the Virtual and Film Salons, Christian Kamir. He's, world known for his presentations, has spoken at many conferences. He's writing a book called Streamed Money or Streaming Money, which is coming out this year. And he is one of the, I would say, best, people to discuss the idea of decentralization and the technology that allows us to have decentralized solutions when it comes to everything, including money. And today his presentation is going to be about all of the issues that current financial markets are experiencing and will experience as blockchain and Web3 come on board. So with that, I'd like to introduce Christian Kamir. Thank you for joining us.
Sure. Well, I'll give everybody the very quick highlight reel about who I am and what we do here, just so that you have some context. So at first, the obvious, the funny accent originated in Germany. Was a software developer for a short period of time in the late 80s, but then went to law school. After law school, became general counsel for one of the first internet service providers, which we merged with what's now the largest ISP in Europe at the height of the dot-com. So I promptly retired from the law, promptly left Europe to move to Southern California in 2000 to set up a venture fund focused on what we call decentralized software solutions. Intermittently ran a startup that we sold in 2009 and then went back into VC. I do a lot of teaching, do a lot of speaking. I'm very passionate about the project of what I call building the web for the first time. My contention for the past 15 years has been that we actually never built the World Wide Web, we built the commercial web. And there's finally more awareness around that. And that's what I'm really excited about. And that's what I'm going to spend the next 20 years of my life doing to bring that to be. So I hate clickbait titles, but create them anyway, reluctantly. So I literally throw a word into a clickbait generator and use that for my presentation. The ultimate goal is simply to educate everybody from our perspective of how we see this space. So we have the advantage of having been in that space. And again, I call it decentralized software solutions for more than 20 years. Blockchain is really just one tool in that particular toolkit. We looked at a lot of peer-to-peer solutions. We invested in voice over IP solutions back in 2000. I was actually general counsel for a little startup that tried to build a unified messaging system in 1994 on the AOL backbone. It was ahead of its time in 1994. Today is still ahead of its time. And now we're gonna move to showing my screen. So here's your clickbait title, The Devastating Impact of Blockchains and Web3 and Legacy Finance, something I've been railing about for a very, very long time. I have to give you the usual disclaimer. Obviously, this is not financial advice, legal advice, any sort of advice. Don't listen to me in respect to all of these topics. Just look at this as one man's thesis on the space who has had the advantage of looking at over 2,000 projects over the last 7 years. We're using the scientific method to investing, which means we write our own thesis papers, share these for peer review. We have our own Skunkworks division for experimental development. We have our own data science team. I work with academia quite a bit. As Mariana mentioned, I'm writing a book right now. At any given point in time, I have 100 article drafts in process. It takes me a long time to get these out because I'm trying to be as intellectually honest and summarize what we're seeing for the benefit of the space itself. And first, what I always do, I zoom out, as in what's this particular startup here that we call the human species. So planet Earth has been some 4.5 billion years old. It has been host to 4 billion species. 99% of them are extinct. And humans are really a startup in this context, having been around in their current configuration for about 300,000 years. And the unique quality that allowed us to survive is that of collaboration that made up our success. I'm going to distinguish this from a couple of other concepts, but maybe as a preface, what we are ultimately talking about here is human collaboration technologies as an overarching theme. So primary problem in collaboration is the idea that I have something that that I want to trade with you. You have something that you might want to give me in return, and we have to kind of come up with a ratio between, in this particular example, rice and chickens. I don't know how to price chickens in rice corn, so we come up with a language for that, and usually it's a language of value. So I offer you $10. It's still a problem, although if my language of value is something else like the yen, then we still have to first come to the primary agreement, which is what language of value do we want to speak. So in short, the primary technology for all collaboration is simply language. And if you are listening to this and you're looking around in your room right now, you will see many, many items around you that if you had to build this particular technology, this particular product that you're using, chances are you would spend your entire life trying to do that and never finish. There's a good book about that was written in 1958. It's really a short essay that describes that particular circumstance. If you had to make a pencil, chances are you would spend your entire life and never finish that. So a subset of collaboration is cooperation. So economies are agreements over incentivized collaboration. So the difference between collaboration and cooperation is when we collaborate, we have a common goal that we work on together. There's no incentive mechanisms. We both want to see this end result in the real world, whereas cooperation usually requires an incentive mechanism. These incentive mechanisms today are mitigated by financial services providers. And finance, from a legal perspective, can be reduced to basically two concepts: the concept of contracts and the concept of ledgers. And now I'm going to give you the shortest overview of financial technology history that you have ever seen. You will typically see anecdotes about like gold doubloons and yap stones and a lot of other like novelty items. All of this is mythology. You can basically ignore that. It's no value to actually looking at these technologies, because in principle, what we're talking about that is that throughout 99% of human history, we simply used our wetware. We simply remembered what we were owing someone and what we were owed. And then we invented this really cool tool called cuneiforms. These were clay tables, the earliest forms of writing, and we recorded these debts and obligations on clay tables until the time when we ultimately invented paper, and then we started creating ledgers and contracts using paper solutions. And then only in the 60s, we started transferring these solutions to bytes and databases in more specific terms. So then we have some niche applications, and that's usually something that people call money. And we're going to divvy that out because people to this day use that term wrong. Everybody keeps using that term wrong. Money is not what you think it is at all. So the typical image I have in my mind is a Federal Reserve note, as in it's a peer-to-peer medium of exchange. It also happens to be the most lucrative export product of the United States, which is interesting. There's only one export product where we create greater revenues from, which is refined oil products. But obviously it's way more profitable to export Federal Reserve notes. It costs about 14 cents to make a $100 note. And while it's legally an obligation, in practical terms, it obviously is never being called in. So when you look at this from a global perspective, then you'll see that as a network technology, this language of value dominates the world. And I think that's pretty intuitive, but it's nice to visualize that in terms of reserve currencies. US dollar leads by far. Everything else is basically irrelevant outside of the euro. There's actually more than 180, so I think exactly 180 currencies, so languages of values out there, but only 7 have a distribution that's greater than 2%. So you can basically ignore all of those. And if you look back in history, whenever one of these languages failed, people typically would revert to the US dollar as their secondary language of value, and they specifically import these cash solutions. And as an externality, almost half of the cash that were produced, about $2.3 trillion, actually is circulating, not inside of the US, but around the world. It's circulating, though, with lower and lower velocity. And velocity is a fancy word that basically simply means how many times is a particular node being turned over in the concept of commerce. So if you look at this graph, what that essentially reads as a Federal Reserve node is being used about, these are quarterly numbers, about 4 times a quarter for the exchange of goods and services. And so when you then translate this to all value transfer mechanisms, then it's really an insignificant amount of use cases where that technology is particularly being deployed. So mostly it's things like debit cards, credit cards, ACH, and so forth. As a side note, before I moved here, I'd never seen a check that's something very specific to the United States. I thought that was really funny when I got a checkbook. Across borders, this is almost more dominant. So most prices across borders are being denominated in US dollar. We pay for everything, obviously, in US dollars that we're exporting. We can enforce that mechanism in terms of unit of account, and only Europe is deviating from that. But 30% of all European trade is also denominated in dollar, and that's mostly because of the import of oil. So if we're zooming out to GDP, and I'm using the numbers for the fourth quarter, or for the year 2021, where we have complete data sets. So global GDP stood at about $96 trillion at the time. Most of that is United States, and which is about 24%. If you combine it with Europe together, it's 42%. And I'll come back to that and we'll tell you why this is important. Just remember the number 96 trillion. And also, I went really, really fast through these, what I call axioms, but these are the most important concepts that you should always recall before you're trying to develop a technology in the context of value transfer. What's this actually for? So what makes us successful as a species, which is collaboration? What is our fundamental technology that's underpinning all of human collaboration, which that technology is simply language? Our society's functional incentivized collaboration, which we call cooperation. And our primary incentive technology today are currencies. So these are the fundamentals that you should keep in mind when you design your technology. And so what we've seen specifically past 1971 is then the unfortunate distortion of our language of value. And oftentimes people throw this term inflation around, not knowing what that actually means. So the primary deflation is really debasement. It's the creation of new currency, of inflating broad currency supply. And we're going to get back to that in a second here, which then this is done through the inflation of asset prices. So specifically, to simplify this massively, every time a commercial bank creates a new loan for a new house, it creates new digital currencies, and there's no new value in the world. So that obviously debases the monetary supply, and that asset is directly being inflated as well. Hence, you've seen the inflation of assets, so specifically housing, but also to some extent stocks as a secondary externality of that, which then ultimately results in overall consumer price inflation. And the Fed plays with their basket of CPIs on a quarterly basis in terms of making this look like it's not 10%. It probably has always been 10% or something to that extent over the past 20 years. So really, from a technology perspective, there's only in the legacy system 3 technologies. One is being issued by the central bank. These are the fiat notes. And this is about 6% of all currency out there in the context of US dollar. Again, the US dollar is really the dominating network technology out there that we're interested in talking about. All others are kind of runner-ups and distant ones at that. But these Federal Reserve notes, so cash is really good in terms of its actual function. It's a bearer instrument. I can do peer-to-peer transaction. It's anonymous. Usually there are no fees attached to that, which is very different if you're using commercial bank money, commercial bank currency more specifically. And I'm taking these classifications specifically from Federal Reserve paper. I have some disagreements with that, but overall, it's directionally correct. So most currency, most US dollar denominated currency is created by commercial banks through the process of lending. So 94% of all currency supply out there has been created by commercial banks. And what's annoying about that is no one talks about that much. There's always this idea that the Fed, quote unquote, is debasing money or is creating inflation or is manipulating the currencies. By and large, is a systemic issue through commercial bank money creation and how this sector is being allowed to create currency. They have terrible legacy technology we call ledgers, or databases for that matter. It's intermediated. We have things like KYC, which is really a window dressing term for wholesale financial surveillance. There's enormous fees attached to that. Essentially, you can summarize this. If you were to move any form of value through that legacy system 50 times because of those fees, then the entire value has been transferred to those middlemen because of the fees involved. So the terminal velocity of that technology in terms of using it for value transfer is 50. And then we have kind of this almost niche application that the Fed calls non-bank currency. That's simply the commercial bank currency that you're storing in other account-based systems. So think PayPal and other payments providers. Then I have an empty slide. Impressive. So enter Bitcoin. Most people don't pay much attention to actually the title of the Bitcoin white paper, which I encourage everybody to read at least the abstract a couple of times a year, because Bitcoin was the first decentralized finance application. Actually, from a technologist perspective, we had instant settlement finality on telecommunication networks for 30 years. So that's actually a solved problem, and it's a little bit misunderstood, unfortunately. And my doctoral thesis was on number regulation for telecommunication system. And we have things like prepaid calling cards. So that's functionally the same thing. But the larger point there being is Bitcoin introduced kind of the first visible peer-to-peer cash solution in that context. Most people refer to it as that. There's many, many misconceptions around there. I'm not going to touch on all of them, but one specifically. And when I was listening to John Oliver a few months ago, he had the statements that cryptocurrencies combine everything no one understands about technology with everything no one understands about money. And that's funny because it's true, even though the statement in itself actually also conflates a couple of concepts that we're going to talk about. And this is mostly the concept of money. So this is a definition that's usually offered for money. It goes back to a little pamphlet that I have here on my shelf that Henry Williams Gibbons wrote in 1875, defining the function of money as a unit of account, store of value, and a medium of exchange. This is wrong. It always has been wrong from day one. No one should ever be using that, and I'll explain to you why. So from a technology perspective, the unit of account is simply bytes. So if I don't have a reference, if I don't have a language of value, then I look at these Bitcoin numbers and they are just numbers. So I add my unit or my unit of account, my language of value to that. If you're in the United States, you probably see your Bitcoin holdings, your Ether holdings, US dollar denominated. And if you're in Europe, you might choose the euro. If you're in Japan, you might use the yen. So again, from a technology perspective, the unit of account is simply an interface function. Then in terms of store of value, we can simply measure these, go out there and see what are citizens using as stores of value in the United States specifically. Well, Citizens store value in stocks, they store values in bonds, they store values in CDs, which are also lending contracts. They store value or owe in terms of owing money on their house. So they store value in their real estate. And then you have a group of lenders on the other side for who mortgages are accruing value in terms of actually earning interest. And then some people will keep some of their near-term holdings in actual cash and or cash equivalents, which would be your demand deposit account or your checking account. And that should typically not exceed 10% and usually should be less than that. Anybody of wealth actually usually will owe more in terms of actual cash equivalents than they keep as a store of value, obviously. And then I made the Bitcoin logo here as a store of value actually bigger than it is. In contrast, you can probably tell because Bitcoin right now is some 500 billion or something. So it would be much smaller. I just wanted you to see this in comparisons of how people actually store value, which is always a basket of things, obviously. So then the medium of exchange observably has been bytes for decades, right? So on the left side here, you see a value that represents a certain amount of Bitcoin. On the right side, you see a value representing a certain amount, exactly $1 of fiat currency, US dollar cash. Whereas the left side is $1 billion worth of Bitcoin, the right side is $1 in US dollars. So how do we do value transfer in the legacy system today from a technical perspective? You got Bob, you got Alice. Bob has an account of Bank of No Returns, and Alice has an account of Bank of Going Nowhere. Then Bob sends a message to his bank to update his ledger, which it will transfer using usually 2.5 intermediaries to Bank of No Return. And at some point in time, these messages will then end up in the reconciliation of these ledgers. Notice that I used the word message. These systems, even though they're being called payment systems, are not payment systems. They are actually messaging systems. Same is true for Visa and others. They are messaging systems. That's why always these comparisons between Visa does so many transactions a second. It's a little bit nonsensical because none of these transactions obviously settle in any reasonable amount of time, whereas Bitcoin will usually, as an example, settle inside of 10 minutes for any amount. So what all of this speaks to is a very, very simple conflation. The conflation is between currency and money. Currencies are technology. Money is a legal agreement. And it's simply a legal agreement over a unit of account and a medium of exchange. That's it. The store of value function is not being discussed in that particular agreement. Point there being is the original definition that people keep using from Jevons was always included a formal logical fallacy, technically a conflation between use cases and functions. And so to make this very easy to understand in terms of a technology example, the technology of a hammer always has the same exact function. It centralizes centrifugal force. And so the use case might be then usually I put a nail into a wall. If I change the use case and bash someone's head in, the functions for that technology weren't touched at all, and I don't use that as a definition of a hammer, and I don't put the word murder weapon on the hammer. So moving on from here to blockchain, now that we hopefully understand the difference between technology and legal agreements and currency and money in particular. So blockchains are not ledgers. Blockchains are not databases. That's a huge confusion. And in order to make this really, really simple, I created a kindergarten version of how peer-to-peer technologies and public key cryptography in particular works. And we have Bob here. Bob has relations with Alice again. And he has values stored in his box here with a lock that he has the key to. He sends that box to Alice. Now Alice has a box, but it's locked with Bob's key. And so he puts her own lock onto that box, sends it back then to Bob, and Bob takes his lock off, sends it back to Alice. Now Alice has a box with a key, and whatever value is inside that box now is under the control of Alice. That's in principle, and again, it's the kindergarten version, and there's obviously more complex systems, but in principle, this is how peer-to-peer transactions work using public key cryptography. Then if you were to look at any of the entries that these transactions, and I'm using the word carefully here because I actually replaced this on here. It's important actually to not call these things transactions. Again, otherwise you are very, very likely going to confuse legal and technology aspects. And I just took the most obvious entries from a blockchain here, and I just picked a random entry from Etherscan. And you basically see 6 things. You see a certain hash number, you see a timestamp, you see the address, maybe this is Bob, who sent it, you don't know if this Bob, obviously, and to a particular address over a certain amount, paying a certain fee. You have no idea if this is a transaction, by the way. All you can tell from this particular entry is that control over a set of bytes changed from one address to another and what the costs were involved. And obviously, that shouldn't even be visible usually either, and a lot of either second layer solution and or client solutions are solving for that visibility problem. As a lawyer, it's very easy to come up with very simple classification of transactions. Really, you can look at value transfer in these 4 large buckets, and then there's a lot of like minor deviations below these buckets, and I'm missing a bracket here. So the typical one would be an exchange, so a payment for a product or service. Secondarily, something could be a loan. And there I put currency creation in there. And the reason being is because oftentimes when we talk about commercial bank lending, we call it lending, but more often than not, it's really currency creation. And so the point here being is from a legal perspective, I can really only lend what I already have. So there's this whole finance space of alternative lending. From a legal perspective, that's really the only form of lending, at least to someone who is very principled like me in that regards. And then you have a 3rd class of transaction where I send you something, I don't want it back. We call it a donation. And then a 4th class, a small class of I send you something and we create some shared interest in a common enterprise. And we're calling that an equity or a security. So on that topic of equity and security, let's move on to capital formation. So the standard form of capital formation is that of a corporation. So you can see the relationship between corporation and cooperation. The problem with corporations is you got a lot of different stakeholders with a lot of different interests. You got operators, employees, clients, suppliers, shareholders. All of them have very different interests. As an employee, I probably want to extract the highest salary I can for my services. As a client, I will want to probably have the best product at the lowest price. As a shareholder, I'm mostly interested in increasing the value of my interest in that company and so forth. And this creates a lot of externalities on a daily basis. Think Google, for example, which is a for-profit company, and its main battle cry is obviously increasing shareholder value. That's just written in its mandate. So the way it does that, it sells social engineering as a service to the highest bidder, which is its business model. So Google is really not a search engine in that sense. And it's my favorite topic to pounce on, and one of the largest problems in the context of value and information transfer more specifically. So then really the most important paradigm that the Bitcoin white paper introduced is that of a decentralized autonomous organization. Because in order to participate in that, you have to either own the mining reward, and it's specifically always important to call Bitcoin the lowercase b, signifying the mining reward, and differentiate this from Bitcoin uppercase b, the blockchain. But in order to participate in this decentralized autonomous organization, you're typically working towards that same objective. You want to increase the value of the network. You want to increase the security of the network. And outside of that extraction, everybody is working in the same direction. And then when you apply these principles, so this principle of a corporation to the principle of collaboration, then you get interesting examples, right? So you get examples of one of the largest banks out there, JP Morgan, having 250,000 employees. And then you see the number of Bitcoin developers here. And obviously, these are just the ones that are lately active. There was 750 people that contributed code. It's just an aspect of this being an open source software project. And also, you should be able to really simply deduce from these numbers that, well, 250,000 employees probably turn on a computer in the morning. They probably get into their car and drive to their offices, and they probably consume some energy. They probably produce some carbon. And it would be great if someone did the math on that to show that my strong suspicion here is that a single bank probably produces way more carbon than one blockchain or all blockchains combined. But the larger point there being is you see the extractive value of JP Morgan, and you see the market cap compared to that. And these are numbers, by the way, that represent the end of last year, just to streamline this. That's why it doesn't show the current market cap of Bitcoin. And if you break it down further, then you see in the past we had things that I call full fintech, i.e. PayPal. The reason why I call this full fintech is technology really should introduce something innovative and not just provide a window dressing solution to the legacy financial system. Because obviously, if you're using PayPal, you're still interacting at some point in time with a commercial bank for your on and off ramp, and it's still introducing an intermediary, and you can still compare how many people work at PayPal, what's the transaction volume, what's the market cap. So other network technology, which I would now call FinTech 3.0, just to differentiate that, are way more efficient. And obviously, to be intellectually honest, these are oranges to apples comparisons. It's just directionally correct. Then people like to talk about cryptocurrencies as a self-inflicted wound that we ever invented this term. As I said, currencies are standardization of a contract we call money. There's no way for anybody, as I mentioned earlier, to determine, but from any transaction, if it even was a transaction, could just me being exchanging an address, or if there was any legal relevance, or more specifically, what legal relevance we should assign to that. We can make broad classes that has directional utility. So we can talk about things as commodities and network tokens that have particular functions, which, by the way, keep changing. Obviously, the original function of Ether was a DDoS protection mechanism. Now people introduce very less helpful metaphors as supersound money. Again, that's just not understanding that money is a contractual agreement that's entirely situational, meaning to say that something is money is a nonsensical statement. Anything can be money, right? Cigarettes butts can be money. Nothing is money. Then we have things that we call stable coins. We have things that we call government tokens. But what we really do as an investor is we see and measure and observe what's the actual utility and what's the actual adoption of these technologies. So I get emails every single day and have for probably 10 years now that have battle cries like blockchain adoption, cryptocurrency adoption, other NFT adoption, whatever it is. That's very much an incomplete statement. Obviously, you want to provide facts like who is adopting it, why are they adopting it, when are people adopting it, and how are they adopting it. Unless you're doing that, you're not actually saying anything. So as I mentioned, I encourage everybody to drop, and I know I'm going to be a neophyte here. People keep using that term cryptocurrency. It's just very unhelpful. It has confused regulators and government agencies to a large extent. The term crypto should always be used short for cryptography. That's what we're talking about. Currency, again, is a particular use case. You may or may not use something as a currency. More often than not, you won't. Then there's an important distinction I always like to make, and you used to be able to segment coin market cap for that. There's actually a difference between what is a coin and what is a token. Coins are the native mining rewards of a public blockchains. Tokens are simply standardized smart contracts and can be thought of as an API function. So then if you look at the current situation, and again, this is just representative, and all of these classes we measure in billions, not in trillions, like we measured the earlier actual stores of value. So most of today's market cap, and I'm even reluctant to use that term market cap, because right now the state of what users call cryptocurrencies is very much kind of at a level of multi-massive online player games. It's by and large disconnected from real world economic activity. And I don't mean this disparaging. It's a good thing to test out these theories in an environment where real world economic activity isn't immediately affected by that. And we should have done that before we introduced the legacy systems, which we failed to do. Larger point there, though, is that you can really only look at these particular classes to see there's a lot of Bitcoin out there that's being measured on these quote unquote market. There is Ether that's being used in different ways as a store of value, and others. There's network tokens, there's meme tokens. But what you really want to do is you want to measure the actual use cases. And if we're taking the Bitcoin example, and we're going to make one other example, the use cases are readily observable. And I give you a simple demarcation line here. So as investors, we put in a line in the sand in terms of what we call an investment. If you're buying something with the expectation of selling this year or even next year, you're not an investor, you're a speculator. And to me, the demarcation line is for technology investments is really a minimum of 5 years in terms of when you can see the implementation, adaptation, and scaling of a technology. So what we can simply measure, given available data this way, is that most people use Bitcoin, the mining reward, lowercase b Bitcoin is the mining reward. And it's not the unit of account or nothing. It's just the mining reward. That's its only function. And it's used for speculation and secondary store of value, and actually made the pie for transactions and payments much larger, obviously, than it is, because otherwise it would be infinitesimally small. But that's where it is right now. It's open source technology. It's evolving. There's second layer solutions that most people will be familiar with. And then hopefully we have more efficient solutions on top of Bitcoin as a settlement layer, using Lightning or something else to actually facilitate other use cases. So particularly, obviously, payment functions. But to make one other example, if you break down the actual observable use cases for stable coins, so this would be the example of Tether, you don't have to talk about anything else but what you can actually measure and observe. And you can simply measure and observe that the primary use case for this particular stablecoin is simply speculation. It's speculation against other digitally native assets. And you can see the assets right here. But what you can then observe as a technologist and technology investor, the velocity, so the actual use case velocity and function within that particular area is almost the entire market cap. So contrast that with what I showed you earlier. The velocity of the US dollar, of a physical Federal Reserve US dollar note, is 4 times a year. So this is 100 times or 100% a day, essentially. The entire market cap of Tether turns over, but it's just for this particular use case of speculation. And then there's a very small amount that really, from a statistical perspective, doesn't even factor in at this point in time, where individuals are using this as a form of denominating payment functions. But again, it's early stages, and companies outsourced from Square actually working on Lightning adoption to eventually bring this to a larger user base. And I'm very hopeful that this is going to happen. So moving from here to actual FinTech 3.0, or what usually is referred to as decentralized finance. Again, what you want to do is look at the use cases. There's obviously way more use cases than these top 10 that I'm listing. There's more than 100 some use cases that you can observe, but these are the only ones that really have any relevant value transfer. So it's mostly speculation on DEXs, decentralized exchanges, then secondary use cases, lending. Bridges is kind of a technical function. CDPs is the most interesting function, so collateralized debt protocols, and I'm going to get into that specifically a little later. Staking yield, we don't have to mention all of that, but point there being is you just want to simply, as a technologist, take a step back and observe the adoption for particular use cases outside of speculation, which, as far as I'm concerned, is just more of the same of what we already have. As it's the game that we call the stock markets today. Trading Apple stock in nanosecond doesn't add any value to real world economic activity ultimately. But what you can observe then is already movements towards that in terms of the adoption of these decentralized solutions, and contrast this with centralized solutions that involve digital bearer instruments. So the obvious example here is Coinbase with over 1,000 employees. They might be below that now. Again, these are all numbers at the end of last year, and contrast that with a DEX like Uniswap, who has less than 50 employees. And you can see how much value they're created in a much shorter period of time and also by being way, way, way less extractive. Obviously, revenues for Coinbase at the end of the year stood at over $3 billion. Uniswap extracted about 174 million during that same time period. And then if you contrast a DeFi solution with a legacy fintech, again, using that marketing term that was literally invented by an advertising agency to sell this to investors. If you're looking at things like Lending Club with 1,000 employees and compare this with a lending protocol like Aave, you can see how extractive that protocol is right now, but it always also provides more utility, hence the larger market cap, and already issued more loans than Lending Club did over its entire life cycle. Then I promised I was going to show you a very simplified collateralized debt protocol explanation for those who may not know that. And I'm going to go back for 1 second here to my main gripe with the legacy financial system, which is that it's debasing the currency. It's distorting our language of value on a daily basis by creating more currency through the process of lending. So whereas if you have a CDP, a collateralized debt protocol, and I want to lend something and I have an asset here, so let's say I have 50 Ether in my wallet, then I can approach this particular DAO. I can deposit my asset into that DAO. I'm not losing it. I just deposit it into that DAO. I can pick an interest rate. At the moment, all of these lending protocols require over-collateralization, which is prudent anyway. But then I can take out the equivalent in a stable coin minus the over-collateralization. So let's say I take out DAI. So I can take that DAI, liquidate that, and use it for real-world economic activity without losing my asset. So in my simplified model of the world, this is how currency creation should work. I have an asset, I collateralize that, and I take currency out and facilitate real world economic activity, because there is no new value. There's just a utility of this particular instrument, of this particular currency that facilitates real world economic outcomes. So there's a lot of very unhelpful metaphors in our space of blockchain-based solutions. The one helpful metaphor is this one. It's basically the one that Nick Szabo introduced in '96 of a digital vending machine. And the literally only function of a blockchain is to build digital vending machine. What I mean by that is you should never, ever use a blockchain to store anything. That's not the point, right? So if you, again, just read the title of the Bitcoin white paper, it's peer-to-peer cash. There's no ledger. Ledger is a functional component of the security mechanism. It's not a use case. So point there being is, Bitcoin was this first digital vending machine, kind of your simple gumball machine. I put in a quarter, I'll turn the dial and I get out my gumball and I can see what's happening. And there's no intermediary involved. So all blockchains provide this particular function. And this function is simply changing control over a set of bytes from one controller to another. And you shouldn't know whether or not that is a transaction. You shouldn't know who is participating in this particular change of control. And if you do, you most likely will, what we call in our due diligence check, invalidate the herd immunity of your application. So I'll give you one particular very simple example. If you commit any personal identifiable data to an immutable record, at that point in time, you're no longer capable of performing certain regulatory requirements, i.e. under CDPR, the right to be forgotten. And that's true for CCPA here in California as well. You can start over. It invalidated your application. You lost what I call herd immunity. Very important concepts. Completely misunderstood. To this day, I ask developers to give me a functional definition of a blockchain. 99% of developers fail in doing that and since use a hammer in the wrong way, largely to bash in their own head. So where are we today? We are still very, very, very early. I sold dial-up services. I mentioned that in the beginning. In the late 90s, we were very excited when the 56K dial-up modem came around and we had 1,500 affiliates running around installing dial-up modems into people's computer. This is basically where we are today. Less than 2% of the internet population is actually capable of participating in blockchain-related activity in any shape or form. And this is being gracious because most of these people probably just bought some digital bearer instrument at some centralized exchange and maybe now self-custody that or installed a runner, which we keep calling wallets. So really what's important to understand, to summarize this, from a commercial perspective, we went through these three areas. We started out with digitizing things in the 60s. That's where I kind of left off in my short history of financial technologies. And companies that accrued value were Xerox, Kodak, IBM, and Apple. And that was a period of about 40 years. And then we introduced web solutions, so digital data transfer, and cloud infrastructure. And then we saw the emergence of companies like Facebook, AWS, and that was a period of 20 years. So over the next 10 years, we will see the solution to the problem that is digital data transfer using data silos, so using database solutions. At the core, what we're fixing is databases. That's the main problem. And the externalities of this problem of these database solutions and those that are facilitating that are enormous. When we first formulated the idea for our first fund here, we looked at all the largest markets and the friction within the market. And If you're moving real estate, the friction in terms of fees is 7%. That's crazy. It's outrageous that the fees are that high, that the velocity is that low. And the same is true for all other large asset classes. Bonds is somewhere between 1 and 5% in terms of fees. Equities is 1 and 2% ultimately. And currencies are the worst. It's 3 to 7%, and often more if you think of the use case of currency transfer in an international context. And just so that we know where we are in terms of the adoption of technologies, I put in the crypto market down here at the corner to compare that. But again, by and large, it actually doesn't interact with real world economic activity. But I hope it will soon, because now we're getting to the summary. Basically, if you just look at the high level numbers of the cost of legacy finance to every one of you out there, 4% of household income, these are numbers by the Federal Reserve, goes directly to commercial banks without facilitating any value transfer at all, without doing anything. 6% is added to everything that you're buying. So let's call these are merchant account fees and buffers that merchants add to the cost of merchant account fees, and accounting for things like chargebacks that are available within these legacy solutions. And then the debasement of currency, and that's the most charitable interpretation, or in a year, is 7%. The increase of currency, specifically as related to the US dollar. As I mentioned, the US dollar as a network technology for value transfer is by far the market leader, and there's no reason to change that as a unit of account perspective, obviously, because it's an interface function. Then if you look back, what is the summary of damages? The summary of damages is $22.5 trillion. This is the revenue that financial service providers aggregated in 2021 when they had their best year ever. So to me, the economy is made up of the sale of products and services, while financial services are simply a conduit to transferring value and transferring products and services. So the revenue that financial services aggregated to me as a technologist is completely a damage to real world economic activity entirely. And probably it's more like 150%, because of all the transactions that cannot happen using legacy financial systems. And here, the simple examples to internalize that: if you had to put stamps on emails today, then it would take the entire GDP of the United States to cover 24 hours of stamps. If we were metered by the minute for phone conversations still, we would eat up the entire GDP within a couple of hours. But we allow these legacy systems, these data silos, these database solutions to exist in our economy, despite the fact that we have peer-to-peer digital bearer solutions and had these actually for more than 30 years at this point in time. But Bitcoin just made it more transparent to everybody. If you're interested in diving deeper into these topics, I publish a few times a year on Forbes. This is kind of the consumer grade version, because they limit me to 1,000 words there. I have longer versions of my thoughts on Hacker Noon. That will typically take you half an hour to read, and I'm writing a book like our host here mentioned, and I'll teach a class at Harvard. I'm largely responsible for structuring Harvard's fintech program. So if you want to subscribe to that, you can find that online. Is a few $1,000s that you have to pay for that. But feel free to just connect to me on LinkedIn if you have particular questions, because I think I almost extended my time frame here, because now, Mariana, we only have 5 minutes for Q&A, right?
Yeah, I also invited you to the Twitter spaces we have right after. So if you have a minute to join us there, we can have more Q&A.
Sure.
It's just having heard you speak on this subject, and Mark Yasko from, Morgan Creek Digital, who's invested in a bunch of Web3 companies and next generation, it is almost, it's interesting that the rest of the world just doesn't even understand how much money we're all spending on these legacy systems. What do you think will happen in terms of conversion to these new systems? What's the time horizon for this?
5 to 10 years. Ultimately, it's inevitable. I have a bunch more slides that explain why that is. I'll give you just a couple of examples. So some that most people will be familiar with. China's rolling out their CBDC this year. And obviously not that I support that, because it seems to be pretty obvious that this is going to be a surveillance tool. This is not obviously what we want. But still, as a technology, it will make their economy more efficient. Much more efficient. It's probably going to be 20% more efficient than the United States, just using, if it's a programmable money solution, which actually I'm doing an interview tomorrow with the foremost expert on that particular topic. And then I can tell you more after that. But so simply other countries adopting that, and other countries also have mandates to have blockchain-based solutions as the primary solutions for all of their government functions. Think the Middle East, you probably saw that, will force other countries to adapt to that simply because of their efficiency in a global macroeconomic environment on current trajectory. Just government spending and entitlement in the United States will just simply be impossible to service. We will not be able to just pay interest on government debt and be able to finance the entitlement programs in the very, very near future, depending on how spending is going. And it's basically unfeasible at this point in time to debase currency more than we already did. But the other forcing function is just simply that we're talking about network technologies. And there's one overriding principle in network technologies that we can take from evolution called the law of requisite variety, which, to simplify, this means that the most flexible element in a system will rule the element. So once I have one digital bearer instrument that settles with instant settlement with finality instantly, then if I can use that for my application, why wouldn't I? Right? So why wouldn't I bring this into my application and be more efficient than everybody else, and everybody else is going to start using that? And it really, at that point in time, it doesn't matter if governments are quote unquote trying to outlaw that. That's always the observably the idea of outlawing things like we're using right now, voice over IP. Voice over IP is still outlawed in some countries, and people are happily using it every day because the alternative is to be either surveilled or be nickeled and dimed by the minute. And so if you transfer that particular forcing function to things like value transfer, it's just 2 orders of magnitude larger in terms of motivation to adopt these solutions. It's just a need. And then the obvious one is that more than 2 billion people cannot even participate in the legacy financial services by virtue of them not having government issued credentials, something we care deeply about. So we consult for NGOs that facilitate value and information transfer to dissidents and living under authoritarian governments. And that's our viewpoint in terms of what is viable technology. As in, if a person like that cannot use your technology, no one should use it. That's our threshold.